Hello everyone, I'm Selin Kasap. I'm a junior electrical and electronics engineering student at Bilkent University. And today I will be presenting you my EEE474 Foundations of Magnetic Resonance Imaging term project. Let me share my screen. My project is about calculating delta B. And here is the table of contents. I will first start by introducing B0 static magnetic field, and then I will continue with my project procedure, my results, and future work. And finally, I will end my presentation with the references. Main magnetic field, B0. It is a static magnetic field, and it plays two important roles in magnetic resonance imaging. First one is, in the presence of B0, the magnetic moment vectors align in the same direction with B0 to create magnetic moments, as you can see in figure 1. The second is, B0 determines the frequency of nuclear spins, which is called the Larmor frequency. And Larmor frequency is given by gamma times B, and gamma over 2 pi is the gyromagnetic ratio. And for water molecules and hydrogen atoms, gyromagnetic ratio is 42.58 megahertz per Tesla. The first equation is the signal equation, and from the signal equation, m times exponential gives us the complex image equation. And from this equation, we can obtain the phase, which is 2 pi delta f TE. TE is echo time, plus phi 0. From this phase equation, we can plot a graph like this. And this phase versus TE graph slope gives us 2 pi delta f, which later can be used to find delta B. For my project, I used this phantom that contains only distilled water. I didn't use any other complex phantoms because I knew the gyromagnetic ratio for hydrogen atoms. Yeah. I used gradient echo pulse sequences for two different echo times. One is 9.84 milliseconds and the other is 5 milliseconds. And after I used the MR machine and extracted raw data, I used MapVBVD to process these data. And I combined the images from the 32 different RF channels, and I obtained these two images, which look very similar. And after that, I looked at their phases and obtained these two graphs. Again, they look very similar. And then I subtracted 5 milliseconds phase from 9.84 milliseconds phase, and I obtained the graph in figure 7. From these data, I found the slope by dividing the phase differences into 4.84 milliseconds, and I obtained the slope graph, which is the same graph, but with different scale, as you can see. After that, I obtained delta B from slope by dividing the slope to gamma. And you can see the delta B graph of the MR image in figure 9. From this plot and data, I found out that maximum of delta B is 1.5 per million, and minimum value is again minus 1.5 per million. I took the average of these data and found out delta B is equal to 3 per billion. And I also calculated the median and variance, as you can see here. For the future work, circle detection can be applied to obtain only phantom space and delta V values, because outside of the phantom is void, and gyromagnetic ratio is not the same for the outer space. And the other thing is, the average of the 32 RF channels values can be taken at very end to obtain better results. And here's my references. Thank you for listening. Don't forget to like this video and subscribe to my channel.